Tiny ITX systems. Not exactly practical, but cute as hell. This is the NCASE M1 with a Ryzen 7 1700, a 65 watt TDP, and an EVGA GTX 1070 for the win. Let's do a build. Now, one of the great things about the Ryzen 7 1700 is that before you overclock it, it's 65 watt TDP. We also took a look at the X370 GTN from Biostar recently, so I thought, hey, why don't we at level 1 put together one of the smallest ITX systems that you can possibly get out there. Now, for this build, we're also going to be using the GSKILL TridentZ. That's the Samsung B-Die DDR4 3200 memory. Now, the overclocking on this motherboard honestly is not great. The software is a little clunky. It's saved by the Ryzen Master software from AMD, where you can actually overclock within Windows. We just got the EVGA 1006 update for this motherboard. It solves a lot of problems, although the UEFI itself still is a little clunky. Then we've got the EVGA 1070 FTW, and it's all crammed in this tiny NCASE M1. I mean, this thing is really just a little bit bigger than the motherboard box. We're using a Corsair SF600 small form factor power supply. We've got a mechanical drive shoved in there, even though that's not really a place where the mechanical drive goes. And our full-size graphics card, and this thing actually runs pretty well. It actually works really well. You can't do an extreme overclock with this. I mean, a lot of people are getting the Ryzen 7 1700 and overclocking it to 4.1 gigahertz. Now, while we're going to use the cooler that came with this CPU for right now, we do have plans to install a Noctua NM-AM4. Now, with the NCASE M1, you got to be a little bit careful about your CPU cooler. You want to get something that will work well, that will pair well with this case. So if you're running something like the Noctua NM-AM4, it'll definitely work with this motherboard. It'll work in this case. There's compatibility stuff for it online, and that's probably the best bet for keeping that Ryzen 7 1700 CPU as cool as possible, especially if we overclock it. Ultimately, we settled on 3.8 gigahertz, a 3.8 gigahertz overclock, because that didn't require us to bump the voltage very much at all. And we were satisfied with the temperatures under load and with gaming and that sort of thing. It was a lot more temperamental for overclocking before we got the EVGA update. We were not able to run the full 3200 for some reason. Maybe once we got everything assembled with this motherboard, we ended up running at only 2933. I feel like that's probably down to the motherboard more than anything, although it's possible having so much stuff crammed in the case is maybe giving off a little bit of interference or doing something funky with the RAM. But overall, the system actually worked out really well. The next upgrade we've got planned for this system is to replace the SATA SSD and SATA mechanical hard drive with a nice high-capacity M.2. But the great thing about the NCASE M1 is we don't have to take the motherboard out to do it. Remember, that M.2 slot on the back of our Biostar motherboard would not normally be accessible, but we've got this great cutout on the motherboard tray in the NCASE M1, so we won't even have to take the system completely apart. We can just pop the side panel, insert that M.2, and we'll be good to go. Now, the NCASE M1 is a real challenge to build in because it is so tiny. I would definitely recommend custom cables, custom length cables for when you're doing your power cables from your power supply. In this case, the Corsair power supply is pretty modular, so we've got a lot of options as far as customizing the cable lengths and that sort of thing. The fan configuration, the final fan configuration that we ended up with this case, is basically all intakes. All the fans that we've got mounted, we've got 220mm fans in the bottom that are intake. The CPU fan basically ends up being an intake behind this dust filter, and then we actually added another fan that's offset a little bit on the other side, just behind the dust filter, again another intake, so that exhausts most of the hot air out the top. The NCASE M1 also has room for a slimline optical drive, so this would make a really excellent home theater system. You could put a slimline Blu-ray or something like that, and this slot that's in the top of the case is for an optical drive that you might install. Now, we're not going to do that. We're just going to use an SSD, and we've got this really great ADATA SSD in here, but honestly, I can't wait to install that M.2. The NCASE M1 also has enough room to run a closed-loop water cooler if you want to, but hey, you know, the Ryzen 7 1700, it's only a 65-watt TDP with our 3.8 gigahertz overclock with the real minor voltage bump. It's really not throwing out that much heat. This is not really an excessively high wattage system. With gaming, you know, the video card's going to put out most of the heat in this system, so as long as we can keep the video card cool and keep that heat exhausting out, you know, outside the case, we're basically in good shape. And this is a crazy amount of horsepower. 8 cores, 16 gigabytes of RAM, a GTX 1070 in this form factor. This is a really, really impressive build. You know, like I say, not terribly practical because, oh my gosh, it's so tiny, there's no room to work. But hey, if tiny cases are your thing, this is pretty much the pinnacle of what you can do with a tiny case, tiny ITX motherboard. If you like this build, you know, please do share it. Please do give us a thumbs up. If you want, check out the Level 1 Tech store at store.level1techs.com. You can buy some merchandise and support us on Patreon, whatever you want to do. Anything is appreciated. I'm Wendell, I'm signing out, and I'll see you in the Level 1 Techs forums.